In order to find the derivative of 1 over x, we're going to begin by writing out the definition of the derivative. So we have the limit as h approaches 0 of f of x plus h minus f of x, and all of that over h. So those two quantities are what we're looking for to plug into our formula. So in this case, f of x is 1 over x, or just 1 over x, and f of x plus h is going to be 1 over the quantity x plus h. And now that we have those two pieces of our formula, we can plug them in and find our derivative. So in our numerator, f of x plus h is going to be replaced by 1 over x plus h. F of x is going to be replaced by 1 over x. And we're going to subtract the two. And we want to make sure we use parentheses or brackets when we're plugging in, so we don't forget to distribute that negative when we do the subtraction. So this is going to leave us with 1 over x plus h minus 1 over x all over h. And what we need to do now is take the fractions in our numerator and find a common denominator. So we can do that by multiplying the left-hand fraction by x over x, which will give us x over x times x plus h. And we can multiply the right-hand fraction by x plus h over x plus h. And that'll give us x plus h over x times the quantity x plus h. And of course, all of this is still over h. Now if we use our common denominator and combine our fractions, and we subtract, we'll have x minus the quantity x plus h over x times the quantity x plus h, all still over h. And if we distribute through that negative from the subtraction, we'll have x minus h, and that will be over x times x plus h, all divided by h. And we can cancel the x and the negative x in the highest numerator there. That's going to leave us with a negative h over x times x plus h, all still over h. And from here, we can remember that dividing is the same as multiplying by the reciprocal, so we can express this as negative h over x times x plus h times 1 over h. And this will allow us to cancel the h's in the numerator and the denominator. So this is going to leave us with a condensed limit, which is negative 1 over x times x plus h. Now we can use direct substitution to plug 0 in, and as h approaches 0, we can see what our function's approaching. So this is going to give us negative 1 over x times x, and if we clean that up, we'll have our answer, which is the derivative of 1 over x is negative 1 over x squared.